Hey, everybody. Here it is, 7:30 on the button here. All right, if we can take our seats, we'll get started. And welcome to the Hazel Park Amateur Radio Club membership meeting for November 12th, 2025. We are in the middle of a solar storm, and so I understand that the with the northern lights could be seen all the way down as far south as Alabama, reports. So anyway, so how that's affecting HF communications, I don't know. But anyway, there we go. All right, here's what we're doing today. Alrighty, so why don't we just start with the pledge to the flag? I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. All righty. Right, so with that, just a reminder, everybody, that the Hazel Park Memorial Library, the building in which we are currently sitting right now, we're very grateful and thankful for them donating the space. And so when you see a member of the library staff, please give them a big thank you. Well, so for the moon bouncing, here we are today, November 12th. It's the last quarter, 45% illumination for those who are tracking such things here. So we're in exactly the last quarter. So that's a perfect mark right there. All right, these are our members. These are our board members who work very hard and do an assortment of various tasks. And so we're very grateful for their work and dedication, and especially the group. There's been a really dedicated group working on this repeater, and we're making some good progress, and we're very happy to report that things are moving along. All right, let's start. So we'll start with Marv, and then Ken, John, Jeff, Hugh, Mark, and Al. So John, KD, I can't see it, but can you say hello first? Oh, can we hear you? You hear yes, go ahead.
Yeah, hi, this is Kilo Delta 1 Indy X-Ray, John. Hello, everybody, and welcome to the Hazel Park Amateur Radio Club.
Terrific. Well, thank you. Thank you, John. All right, Marv, are you there?
Yeah, I'm here. It's Marv, Whiskey 5 Delta Tango. Glad to be
All right. Go ahead. Okay. Thank you, Marv. All right, Ken Lord, are you there?
Yes, Kilo Echo 8, Sierra Juliet Whiskey.
All right. And John WATOY, for whom we appreciate the fact that we can be remotely accessed on the web, thanks to John and his good work there. So, John, you want to just say hello?
Yeah, W8TOY. Hello, everyone.
All right, Jeff Graff, go ahead.
Jeff, Kilo Alpha 8, Papa, Hotel Papa. Hello, everybody.
Hello, Jeff. Hugh, are you there?
Hugh, Kilo Echo 8, Bravo Echo Delta.
Excellent. Mark, go ahead.
Yeah, Mark, W8 MAF, and good evening, everybody.
Great. We hear you loud and clear. And Al, K8, go ahead. You're muted. You're muted.
There you go. Good evening from Alpha Lima Hotel, Al in Berkeley.
All right. Well, let's take a look and see who we have here in hold on. Let me just pan the camera around.
That's one way to do
How's that look? How does that look, huh?
Hey, sweetie, come
There
on.
we go. A little There we go. All right, who's not here? Oops, too much? I don't know. I can't zoom out totally, but all right. Let's just start with well, go this way, right? Ken, you want to lead? Reuben, you're up first.
Kilo Bravo 3, Echo Hotel Whiskey.
10, AD8M. Been a long time. Good to see you all.
Andrew AJ0WX.
Mike, can you HHC?
Les KFAUU.
Vladimir, W8BPA.
Great, still waiting.
Wes, AC8JF.
Don't call. Nate KE8TRJ.
Mike, November 8th, Victor Delta Zulu.
When student.
Larry, KE8LXA.
Bob, N8REL.
Brian, N8RLN.
Art K8ACW.
Bob, WB8ATZ.
Donald, AD8NYD. Kevin, KS8KS. Dino, AD8ZXY.
Brian, Whiskey 8 Bravo Papa Delta.
Leonard, AD8FA. Jay, WB8SPI.
And that's it. Well, welcome everybody. And I'm Joe, WB8ADX. All right. Adjustment here. Oops. All right. Okay, so well, there you go. There you have it. All right. All right, what's next here? What do we got next? Oh, let me get this out of here. Thank you, everybody. Somehow we went in the wrong direction, but that's okay. All right, we did that. We did that. And again, thank you, the Hazel Park District Library, for providing the space for us. The moon, the last quarter. Len is going to talk to us just for a minute about tags.
Badges here, most of you have gotten your badges. If you ordered it, it's tag here. And if you need one, let me know, we'll make a note of it, we'll make another order.
Okay, so for the folks at home, I'm not sure you heard that. Len's all the way in the back, but he's working on the badges. You can see here a good example. I don't know if you can see this or not, but right there. So if you need a badge, get a hold of Len and he'll fix you up with that. All right, our club committees, as we look at every month, I would like to maybe address a little bit the holiday party committee, of which is not really a committee. It's more of a, everybody's going to show up, and we're going to do that. That'll be next meeting. Yeah, next meeting. How about that? Okay, so we'll be right here. Bring your favorite dish, dessert, or whatever, and share it with the club. So it's always enjoyable. Bring your favorite person with you. Always welcome. All right, next. Oh, so let's talk about Help Wanted a little bit. This is a little bit out of order, but so as part of our project of the repeater, this is a little bit pie in the sky, but when it comes to designing an overall network, you got to start big, and we're only working on this part right here for right now. But the point is, we are really looking for people who are interested in learning or have experience in microwave point-to-point communications. And the reason is because we'd like to establish these links that is not terrestrial connected, but connected over the air. And that gives us a lot of protection against should the internet go down or whatever. But what we would like to do is to establish this network. So we are looking for people who have experience or a desire to learn more about point-to-point communications. We own one of these links, and we're getting the two antennas together. They're both on the ground now. And I need to get with, I think, Hugh and we'll get that other antenna picked up, and we'll get the system working back to back. But anyway, please, if you know anybody might be interested in this, it's a great project and really important. And these are some of the other activities around the same, the same kind of technology. So, and then second of all,
What frequency are you working?
we're working on 5 gig. There's a part of it's the unlicensed band in the 5 gig, and then right underneath that, directly adjacent, I think there's 5 channels of amateur radio only. So they're just up against each other. We're actually, ideally, would be in the amateur radio band. So this is, I think, what is it, 5.2 gig? I think something like that, something in that area. And I do have something that can demonstrate. I wonder if I have it here. It's a printout of what all the different channels actually are. And we don't seem to see that right now. Okay, that's fine.
Who's leading that project? Good question.
Good question. Who's asking the question?
It just comes to.
Well, why do you ask? Let me know if you're at all interested. Andrew's working on it. Who else is?
HOO.
Is working on it. Dave is working on it. We have quite a cast of characters there. Really, it's where we're going towards the future, and it's a technology, and it's very interesting to get that sort of thing going. All right, next thing, QSL manager. The QSL manager here. Okay, we're also looking for somebody who can help out with that, and I'm not exactly sure what that entails, but it's a couple of we've been getting these through the email, and they've been forwarded to me, and I'm trying to keep up with them, but not always. So this is another area if you're interested. What? Nobody that I'm aware of. I don't know who was. I don't know. Oh, I know who was. Tony. Tony was doing it. Yeah.
So, Murray was doing it. That might have been a while ago.
Oh, I'm glad you brought that up. Murray was doing this. Murray was. What happened here?
Yeah.
Murray was working on the this part of it, on the QRZ page. It's actually in his name. And this also needs to be updated as well, as you can see. This might answer.
I think he also did our logbook of the world.
Yes, I bet he did. Yeah.
I mean, is he still doing this or not really?
Not really anymore. We don't have anybody doing it. So this is an issue. So if you have a desire to help out with the club, it's an easy way. The whole thing takes 5 minutes a week, something like that, whatever. But let Reuven know, and he'll pass word along, and we'll get that organized. All right. Don't forget our license classes. Okay, our license classes.
With the help, we want to acknowledge 2 volunteers. One is our newsletter editor.
Oh, of course.
And our webmaster, Ken, he's on Zoom here.
Where is Ken?
Ken is on remote.
Ken, are you there? Ken is there. Yes, he is. Ken Lord is there. I think he's being consumed by the Aurora right now, but he does, he may be swallowed up in that. But yes, and Mike, thank you for that. Mike is putting together the Zero Beat has now come back to life.
Mike,
K8WU. Yeah.
He has uploaded the website, so I think I haven't gotten into it yet, but
Right.
it's supposed to
Oh, good.
be better. And it's been suggested and requested that we try to recruit somebody for a possibilities of a swap again. If there's any interest in it, if somebody would like to head that up or work with somebody else on it, explore the possibilities of having a swap again. Let Joe or myself know.
Yeah. Yeah. Mike, go ahead.
Just while we're on the subject of the newsletter, if you got anything to say, if anything happens, if you did something, if you saw something, if you want the club to know something, send it to me, please. I'm always looking for stuff to put in. The newsletter, if you didn't notice, came with Reuben's email Monday morning. So that's how it's gonna get distributed. It will also be archived on like it is now on the website, like it always has been. But that's where you're gonna get your own personal copy is, when Reuben sends it out on, the Monday before our meeting is the, publication date. So if you got something you want to say, please send it to me. If you can write the article, that's even better.
Yeah. Yeah,
How do I make sure I'm on that email list? 'Cause I don't remember seeing it on.
You could send these.
Everybody else saw it on Monday?
Yeah.
We're in a little bit of an odd place in terms of the membership roster and how that gets into the email list. And until we get that really fully sorted out, the maintenance of the email list is kind of manual, and that when people send me an email saying, hey, add me, I'm doing it by hand. We used to have it sort of automated that we'd export the roster and import it from the email, and that kind of broke down.
So to answer your question, let Reuben know. He'll help you. Reuben's trying to figure it out. Look it's a process, and there's some certain disconnect.
Just missed it. My emails are, yeah.
Yeah.
Well, and if you don't have it, as soon as I send it to Reuben, or as soon as I see Reuben's email come out, I go onto the website and I put it in the archive. So you can go to the website right now. If I go on our club website, I will find the current 0B. Correct. Brilliant. Thank you. No, it's not on the front page. It's on the,
Yeah, it actually is on the front page right now.
Can I put it on?
Someone posted it as a link on the front page.
Oh, I think that's when, we had some trouble getting it onto the archive page. And, Mike Phipps sent us instructions on how to do it. And Ken went in to do it and said, it didn't work for me. I don't see it. I did it, but I don't see it. And I had also done it and it worked for me. So we could have had it twice. I didn't know Ken was doing it, but I think that's where Ken's went. So
Yeah.
it won't be there normally. Don't look on the front page normally. It'll be in the archives. Thank you. Yep.
All righty. Well, thanks for working on that, and we're glad to see the 0B coming back. All right. Where were we here?
Wait, go back to that page, please.
Which one?
The education page. Okay, may I have just
Go,
a minute?
please. Yes.
Okay. Right now, we've got a technician class going on. We've got a general class going on. Starting in January, there's going to be another general class starting on Monday, January 12th. And the extra class is starting up in January, on January 6th.
The Tuesday, yeah.
Tuesday, January 6th. All right, we're not gonna run a technician class in January. We're gonna do that again next year. Now, important. Many of us, several of us who are part of the education team, we're getting older and we've done this for a long time, and we need people to step up to teach these classes. Jerry, has been, I think Jerry's been involved in this since, Jerry, W9 NPI, since around 2010. And, I think he kind of wants to move on a little bit. I've been involved with the technician session since 2019. We've done 13 sessions of that since I've been in it. Wes has been involved with the general class since 2017 or 2018, something like that. It's like we've been doing it a long time. Come on, guys, it's time for maybe some younger people to kind of get in and teach these things.
But put it in the newsletter and contact BBC. Okay, Les will do, if you want the channel. Hey, Ray, look, guys, we do need volunteers to kind of step up and kind of take over, because the people that have been doing it now have been in it a long time. And it's time for some fresh blood. All right, thank you. You're going to be hearing about this again. Okay, thank you.
Follow this class.
Yep.
Yes.
And-
Classes will be on Zoom.
Yes, and remember, the club motto, of course, is service through education. So would like to get some fresh blood in there, and also be able to get a number of people interested in taking the class as well. All right. Yeah, so we will, yeah. By the way, once you do get your license, I just want to say, all the rules have changed and we're doing this different. So maybe this slide needs to be updated, but we're not giving the testing anymore. I think there's a new system, and to be announced very shortly on what that procedure is going to be. All right, now, so we did this survey. Len came up with this idea to kind of get an idea what everybody wanted to, what the interest was, right? So I thought we'd talk about two things today, but we're only going to talk about one. So we're just going to talk about, well, not exactly kit building, but if you're building a kit and you need a printed circuit board,
Yeah.
I think the information that you're about to see is going to be very important. So here we go. Andrew Johnson AJ0WX. Andrew?
Anyway, so
Yeah.
good evening, everybody. So, like Joe mentioned, not necessarily about kit building, but one of the things that DIY PCB design kind of allows you to do is a lot of the stereotypical kits that you used to have, Heath kit and stuff like that. They don't kind of make those anymore, but there still is that kind of spirit where a lot of people will put together like their own projects, their own PCBs, and post everything online. So instead of a kit that you order, you could actually freely download the plans and then send those plans to a fabrication shop where they'll build the PCB for you, assemble, whatever you tell them to assemble, and then you could take that board and kind of build it like you would a normal kit. So one of the things that PCB fabricators kind of opening their doors to the hobbyist market has done is allowed stuff that you normally wouldn't see as a kit. You can get it as a kit form. My favorite's been the True SDX. It's a software-defined radio, HF radio. So it's pretty cool. QRP low power. Definitely not a first kit, but it is out there. So like I mentioned, it's always kind of been a part of ham radio is building your own stuff. And part of that is assembling custom circuitry. So, with the Heath kits, everything was kind of point-to-point wiring. So a lot of you that have been in the hobby for a while, this probably looks really familiar. For some of us younger guys, we've only seen this, in magazines. But one of the issues here is since you have to run a wire from point to point to point, once you start getting up in the higher frequencies, like, VHF, UHF, you start to run into issues there, trying to, put all the stuff into a little box, room for all the wiring. But good thing is if something breaks, it's just wires and a component. So it's a lot easier to kind of, fix it when it does break. And then as integrated circuits came out back in, 70s, 80s, 90s, we kind of started to move away from this construction because, it's a lot easier to kind of do stuff nice and tight and tiny with the integrated circuits. So perf board construction, this has kind of been the gold standard for DIY work, for decades. You could actually put all the components in the holes and solder it on the backside. So, it's nice and secure, it's nice and compact, and you can kind of see those copper traces. So it kind of helps you to do a little bit of wiring, right? You don't have to have power or ground running anywhere. You can have like a bus bar, a little bit easier to build. So the one downside though is with surface mount, you have to have breakout boards and stuff like that to get a surface mount device on here. And similar to a breadboard construction, I know a lot of the Arduinos come with these. You can kind of just put the components in, no soldering needed. The downside there is, if you drop it or something like that, you lose some parts. So it's not super permanent, but it is good for prototyping and, just to test stuff out. So that brings us to the main topic of today, printed circuit boards. So what is a printed circuit board? Well, a printed circuit board is a board that electronically connects and mechanically supports all of the components needed to, perform a function. So pretty much anything, made within the past, I don't know, like 40 years, if you crack it open, you'll see a circuit board instead of, point to point or anything like that. So it kind of is what gives the ability for the designers to kind of, shrink everything, put everything, down into a nice HT where you can, stand here. So, what is the PCB? So, um, having the wires go from point to point where you'd put your components, and then you also could have through-hole components like your standard resistors, capacitors, or anything like that. These holes right here are called vias, and that's how you can kind of go from the top side to a different layer. So as I mentioned, you can have through-hole or surface mount, and then connection between the different sides. You have these vias. And then just some other terminology. The solder mask is the color. If you didn't have this on, everything would be either shiny copper or kind of dull substrate. So in this case, it's a red solder mask. In this case, it's a green solder mask. And then you have your silk screen, which is kind of like the legend or anything that you'd want to say on the board. Oops. On my now that we kind of know a little bit about what a PCB is, how is it made? So it starts off just with a non-conductive substrate with copper on either side of it. You can either have a single layer or double layer or a bunch of layers. So this is kind of how each layer would be assembled. So you drill any holes is kind of the first step through your through-hole components in your vias, and then you'd print a resist over where you want the copper to stay, and then you etch it and either chemically or with a UV light or anything like that, and it actually melts away the copper, leaving just the copper that you want to have as your traces or footprints or through-hole components. So as I mentioned before, you can have any number of layers. Most hobbyists use 2-layer boards as they're a lot easier to make. Once you start stacking layers, you have to align everything. And as you could imagine, especially if you're working with really tiny spacing, trying to get all of those to align perfectly is kind of a chore. So, 2 to 4 layers isn't too bad. They're definitely within the price of the average, hobby build. And one of the benefits once you go more than 2 layers is you could have your top and bottom layers be power and ground, and then run all your signal on the inner layers. And that's good, especially for RF stuff where you're going to have a lot of RF interference and want to mitigate all of that. So creating your own PCBs. Again, this is before my time, but I've actually in college played around with this just to say I did. You used to be able to buy everything at Radio Shack to make your own PCBs. You'd have to paint the circuit, or they had these little stickers that you could put on the copper, and then you just set it in this etchant solution, which apparently was really toxic and you couldn't get rid of it. But yeah, and especially because it had all the copper in it afterward. So this wasn't really bad if you just wanted to do like a quick and dirty circuit board with a few larger components. But if you wanted to drill holes and stuff like that, you'd have to, make sure you had a drill press and template, and just trying to get everything lined up and so the components would fit was kind of a pain. But for through hole stuff, resistor to resistor to capacitor, it wasn't too bad. I actually used this method to make a UHF VHF diplexer. So it turned out pretty well. Didn't look pretty, but it did work. So it kind of limited it to the extreme hobbyists, the people that didn't have like a significant other complaining about like, oh, you used the good Tupperware to etch a PCB and then now we have to throw it away and all of that. So as kind of everything's kind of progressed and we've become more advanced, a lot of fabrication shops has opened up. So instead of having to do this, in your basement or kitchen or whatever, you could send the design out to a fab shop. They'll fabricate it for you. Some of them will assemble it, and then it arrives at your doorstep. And you just have to pay $20 or whatever. So going into that, I'm just going to kind of go over the three fabrication services that like I've had good experience with, either directly or indirectly. So the first one is JLC PCB. They are based in China, but they do very quick turnaround assembly as well as PCB fabrication. The price you really can't beat if you're just doing circuit boards. It's about $2 to $10 for 5 2-layer boards up to 100 millimeters by 100 millimeters. And like I said, you just send them the files. They check it. They say, okay, we're going to build it. You pay, and 2 weeks later, it shows up at your doorstep.
Make a note about this company. If you send something in that's wrong, they check everything.
Yeah,
They will note you back. We have an email.
yeah, and that is a good point. For those that didn't hear on the call, they do actually a design rules check. So they'll actually have someone look at your design when you send it in and say, hey, we noticed that this was wrong or that was wrong. It's happened to me where I misspecified a component, like the footprint didn't match the component. So it is definitely a good service. The assembly, like I mentioned, if you don't want to solder the surface mount devices, you could actually, it's a $25, I think, for the setup fee, and then per component cost after that. And so you could actually get a full project board assembled to your doorstep for under $100, depending on, the components that you're using, which, back, years ago was almost unheard of. The one downside, and I haven't used them since all of the tariffs and all of that went into effect, but they are located in China, so there is some customs concerns with the tariffs and all that, as well as the shipping time sometimes could be, 2 to 3 weeks. The second one that I've used a lot is HPARC. They do not do assembly, they only fabricate PCBs, but they will also make you a stencil for surface mount. So it's a lot easier to apply solder paste and build it yourself. This one's $5 a square inch, and you'll get 3 boards. And like I said, assembly is your responsibility. If you're just doing stuff with a lot of through-hole components or smaller PCB, this is actually a pretty good option normally. I have some examples here. I'll pass these around in the room for now, and then show kind of some of them online. So for example, you can see this one. This one's a HPARC one. They do purple boards. And then the JL PCB ones are green. So here's an example of one of those. You can kind of see. So we'll go and pass these on to see if everyone wants to see. These are all various boards of different projects that I've done. So the last one I haven't used directly, but I've heard some good stuff. It's Flash PCB. They do assembly as well, and all of their quoting's automated. I guess they use AI to do it. So I don't know if anyone's ever used them, let me know. I haven't had any projects that's needed a PCB, but I did find that this is an American company that does assembly for a decent price. So just to go into a real world use case on, when would I ever, need a PCB fabricated? I bought a tuner at a swap, and like those of you that have bought stuff at a swap know, sometimes everything works great. Sometimes, you got to replace the switch, and sometimes it doesn't work at all. So in this case, the tuner worked great. Tunes up almost anything and making all kinds of contacts with it. However, the meter right here, the forward power needle was broken, so I couldn't actually measure power SWR. So I was like, okay, well, it was $80 at a swap. It was a great tuner, everything else. I'll just replace the meter. Well, they don't make that meter anymore and probably haven't for, 10 years now. So I really couldn't get a replacement meter. When I said, okay, well, it's a pretty simple concept, right? It's just measuring a voltage that corresponds to an SWR and power. So I could make a circuit board that does that and then display it on a screen. So instead of buying a whole new, tuner or meter, I just made a digital screen. So it'll show me the power, reflected power, and then SWR. So like I said, it's a kind of allows you the ability to, fix stuff that you might not have otherwise been able to fix. And like I mentioned at the beginning of the presentation, a lot of the current day kits, instead of actually buying a kit, you could just download the plans and all the fabrication files, send those in to, JLPCB or HPARC or whoever, and then build the kit that way. So the next couple of slides we'll go over, like if you kind of wanted to get into building your own PCB, even if you don't want to send it to be fabricated, if you want to try your hand at, using the software that you would use to design it, you could learn a new skill. I'm kind of all self-taught on this as well. So, but it, like I said, it is definitely a marketable skill. And it is something that's kind of good to have in your back pocket if you ever wanted to get into, more electronic design. So everything is done in a software that's called EDA, or Electronic Design Automation Software. And the one that I usually use and recommend to most people is KiCad. The biggest benefit, it's kind of a one-stop shop. You could design your schematic, design the PCB, as well as run simulations. And the best part is that it's free. So it's both free to download and do whatever you want with, as it's open source, and it's also free as in cost. Yeah, and there is a lot of support. There's a ton of plugins for it. You can go on the forum and say, hey, how do I do this? And you'll probably get 20 answers. So yeah, here's the website. It's just kicad.org if you did want to download it. Like I said, it's a pretty good program. Does a lot of cool stuff. So step one would be to design the circuit schematic. The software has a library of a ton of components. So you have, resistors, op amps, transistors. They have like a whole Arduino board interface. So if you could think it, it probably is in the software. And since it's open source, if it's not in the software, you could really easily add components to it. You just have to give it the footprint and then like the symbol that you want to use. And there's a lot of libraries you can get online of people that have kind of already done this. So if you say, oh, hey, the specific transistor I want isn't in here, you could probably find it on a library somewhere. And then
if not, manufacturers on the spec sheets, some of them will have that readily available for you.
Yeah, and that's the other good point. If you use Mouser, I know has like 90% of the stuff I found on there, they have a button. I think it's called Easy EDA. You can click it and say, I want to use this part, and it'll download the model, the footprint, and all of that, which is, it's really nice. So once you have your schematic laid out, again, you could use this even if you wanted to do like you weren't going to build a PCB, you just wanted software to design a schematic. You can use this for that as well. With wiring diagrams, anything like that. Yeah.
Can I make a point about this?
Yeah.
Yeah, I do a lot of design work.
Speak up.
Okay. KiCad is a great program. I'm not gonna knock it. However, I do a lot of design work, and I start out on a napkin and a concept, and eventually they grow into a huge schematic. And the way we write schematics is the way we write sentences. So start with it goes into, it goes through whatever the op-amp is, so on and so forth, and we finally come out to the end. And this way we have an opportunity to read exactly what's going on. Well, once it goes into KiCad, it just goes into a box with some little points and fingers. And when you pick that up, my own designs I cannot follow on KiCad. So I keep one on one side of me and the KiCad on the other one and deal with the board. So don't try to do KiCad only. Draw your schematics out by hand with the symbols so that you know what you're doing. You get lost if you don't.
Yeah, I haven't done anything that big yet, but that is a good point. Yeah, once you do get to a certain, yeah. Because this is kind of limited to one single board. So if you have a design that's spanning multiple boards, you start running into stuff like that where it's like, oh, I got to trace this signal and all of that. So that is a really good point, though. So and that's kind of ties into this point number 2. So once you have your design done, you don't want to just send it off to be built. You want to make sure that your design is going to work the way you think it is, and not, you're not just going to say, oh, look, it should work like this. So you want to either build it and prototype it or simulate it at the very least. So like I said, KiCad has a what they call a SPICE. It's an acronym that stands for something circuit emulation or something like that. But it's basically simulating like frequency response, voltage response, transient response, and all of that with your system. The other thing that's kind of cool is there's this falstad.com/circuit, and it's actually an online Java applet that you could simulate quite a bit of different components with. So stuff that's really simple like op amps and mostly passives and some transistor stuff. This website's actually pretty nifty because you could just build your circuit here and then play with stuff, see how it responds. And that kind of gives you a more confidence that when you do send your design in, what you get back is going to be functional. You're not going to have to, scrape traces and solder, jumper wires everywhere. So once you've made sure that your design is good, you want to actually lay out the PCB. So the thing is, though, the software is not necessarily going to do it for you. There is some limited capability of what they call auto routing, where it'll go like what it thinks the best path is, which, sometimes it'll work, a lot of times it won't. But when you actually say, hey, give me the PCB, it's just going to plop all of the components down in no order at all, just plop them right down on the screen and then show you these little arrows of what's supposed to be connected where. And that's called the rat's nest because you can kind of see it's just a huge, huge mess. So what all this does is it tells you need to connect this pin to this pin over here, this pin to this pin over here. And the way you do that is you could drag and drop your components to where you want to have them laid out. And then you could say, okay, I'm going to click on this pin and then drag your cursor to the next one. It'll, populate the trace from pin to pin. So it's almost like a game because you have to kind of say, okay, I want to route this pin over here, but this pin over here. And I can't do that on the same layer because you can't have traces cross each other, right? They have to be either on the front or the back or an internal layer. So sometimes you have to do creative routing. And you could probably see it on some of those where you might have one pin that goes pin to pin this way, and then the other one you have to actually route it around and down and then back up. So it's not always the point to point. So one of the good things though is, like I mentioned with the fab shops, is the EDA software actually has what's called the design rules check, where you say, hey, can you please check my design? And it's very nice because it'll tell you, hey, you messed up this connection, or hey, you're missing this footprint or something like that. So you don't have to. Yeah, because it'll pick up stuff that's not errors sometimes. You just have to know when you could say, okay, I'm going to ignore that, or when not. So this is probably the hardest part of the process because you have to say, okay, I want to make the board as small as possible, choose how I want to lay out my components, and then make sure everything is accessible via, routing the trace. So just some pointers there, if you decide to go home tonight and download KiCad and, get right to it. And this is how I do it. Like I said, I'm not classically trained. I just kind of picked it up as a hobby. So there might be better ways to do this. There might be worse ways, but this is my way. I always start with positioning kind of the biggest and most critical components. The ones that'll say, this has to be on this edge because the user is going to need to access this to adjust something, or the mounting holes to say, hey, I want to put my mounting holes here and place everything else around it. And then from there, you can kind of start with the biggest components and then work your way down to the smallest to kind of try to get everything fit in the most compact space possible. You can use both sides of the board to place components. So I think on one of the examples I'm passing around, you can kind of see that. One of the tips, though, is if you're having the fab shop assemble it, if they have to do both sides, that means they have to run it through the machine twice, which again costs more money and more setup time and all of that. So if you can, I always put all the smallest stuff on one side, all the stuff that I don't want to hand solder, and then the bigger components you could put on the back side and then, do those by hand so it's not as bad. So just some more layout tips. When you're having your traces cross, you really don't want to run traces parallel to each other, especially if it's like a power and a analog signal or like a digital communication and an analog signal. You kind of want to keep those as separate as possible. And then when you do cross, have them cross at right angles. You also want to make sure, you can kind of see this picture here, the red and the blue are the ground copper pores. You want to have as much of a ground plane as possible, especially if you're doing anything analog or RF. When you're using SMD components, a lot of times you'll see a footprint that's called hand solder. You can kind of see here how the chip leads only come out to about here, but the whole pad extends a lot further out, and that just helps you to get more surface area to get with your soldering iron or hot air gun, to where instead of trying to solder like a really tiny chip on a really tiny footprint, the footprint's a little bit bigger, so it makes it, that much easier.
That's for heat dissipation.
Oh, that's good to know. I don't think like that.
I think we start doing that.
Oh, it's for heat dissipation. So since you're hand soldering, you're not controlling the temperature as much as a reflow oven would.
Operate.
Oh, okay. Yeah. So the other thing too is I kind of mentioned here, if you have a component like a motor driver that gets really hot, that's a good way to add heat sinking to the chip. So instead of
Big copper.
yeah.
Big copper piece. Cuts ground out around it.
Yep. So that way you could dump the heat into the copper instead of having it stored in the chip and then causing, issues with thermal derate or anything like that. So once you have your design all laid out in your PCB where you want it, you can send it to the fabrication. Almost all of the EDA tools have a button or like, 2 buttons you can click, and it'll export all of the files you need. The 2 main ones are the Gerber and the drill files. And that's kind of what tells the manufacturer, hey, this is how you lay out the traces. This is where you drill the holes. This is how big the pad should be. And those Gerber and drill files are what you would need if you wanted to, make your own kit, so to speak. If you saw a project online, then they say, oh, hey, like if you want to build this yourself, here are the files. The 2 ones that you'll need are the Gerber and the drill files. And then if you're getting it assembled, you also need a bill of material and the placement file. And that just says, these are the components that need to be installed on the board. And this is the location and orientation of those components on the board. So if you're going back to my true SDX example, they kind of have all of those files in in the JL PCB format that they use. So all you have to do if you wanted to get one of those kits, you could buy them, I think now, because there's someone that's making them. But before, if you wanted to get one of those, you could just download those files, send it to JL PCB, and then they'd send you your boards, your 5 boards. And stuff like that, if you ever wanted to do like a group buy, it makes a lot more financial sense, right? If you say, hey, I want to build this project, let me find 4 other people that want this project. You could all go in since they give you 5 boards. And then that way you can, get all your projects directly from them and not have to worry about everyone paying for shipping or everyone paying for setup or anything like that. And then if you are leaving stuff that you're going to assemble by hand, you just leave that off the bill of material. So if it's not on the bill of material, they're not going to put it on the board. So let's see, hopefully this works. This is just a, am I going to have to click that?
Yeah, talk about the building material, when you're working with this iPad. Every component has to be defined, what size it is, what rating, so on and so forth. So as you do this internally, it's already generating the bill of material. We take that material, that bill of material, export it and pump it right up to Mauser or to Digikey, and it's ready to work. However, I would suggest you.
Yeah, that's a good point. There is a plugin that I know of for KiCad that you could you say, hey, for this resistor, I want, a 10 ohm, quarter watt, 1206 SMD package. And then it'll actually search Mouser for that and then give you the link. So you could just say, like, once you have everything, click the generate button, open the Excel file, and then go link by link to, order all your parts, which is pretty cool. So this video, if it plays, is it gonna play? No, it's not. Oh, wait, because I forget you have your thing backwards.
It's the left. What are you trying to do? Just click on it.
Yeah, it's not it's not playing. Where's the
full screen?
I can't find the where's the mouse at?
Right, hold on, right there.
Okay,
So-
where's the screen?
Oh, go back with your clicker. Yeah.
It's not playing, but
Oh, playing.
Oh, it's
Yeah, it is.
It's oh, I bet when I converted it. I didn't
where's
realize
the monitor, where's this monitor
Here.
compared to that? How do I make it on this screen? Yeah. I want it to be on this. I want to close that out.
Yeah. Okay, hold on. So let's just do it the easy way. We'll just. Come on.
Oh, it's on.
Okay.
Here,
Hold on, I got it on here. There you go.
They got a weird soundtrack too. If you wanted to have like a little rave as you're watching your PCBs get built. But this is just a YouTube video I found of they're trying to sell you the machine for like a couple $1 million, but so it's basically this is how your PCB would get fabricated. You can see these all these down here, the component rolls. Oh, I'm gonna turn the sound off. There we go. Makes it easier. Yeah. So you can kind of see as the these probes will come up, pick up a component, move it over. And you can see how fast it's doing it. I think this is in real time. It's not sped up or slowed down. So it's just picking them right up, plopping them right down. And before the this step, it'll actually the board will go through, they'll put the solder on all the pads, and then they just drop the component right on the solder. And then after this, it'll go through an oven where it'll melt the solder, everything kind of bonds, and then you're good. But no, this you can see this is a lot easier than sitting there with the microscope and tweezers and all that, trying to get everything lined up. You can even see it'll do larger components like capacitors. So this is kind of what you're paying for when you're paying for the assembly. So sometimes it's worth it if you have, lots of little tiny small things. Other times, you could kind of save your money and DIY.
computer escape.
So. So one of the things here, though, is, as I mentioned, these are the roles of components. So you could only have a limited number of different parts at a time. Otherwise, they have to swap those out. So for example, if they had 20 here, but you had 25 different components, that's an extra step where they'd have to kind of take stuff out. So it might make sense from a manufacturing perspective. If you have a 10 ohm resistor and a 20 ohm resistor, to say, okay, make the 20 ohm resistor 10 ohms. So that way, instead of having to swap out, parts as you're building it, you could just kind of run everything all through at once. So going on, like if you said, hey, I'm going to try to assemble this myself, you have different tools available to do that. So this right here is a stencil. And how this works is you basically lay it over the board, put solder paste on top of it, and then use a squeegee to kind of brush it over the holes. And what that does is it gives you a nice level solder amount on all of your pads. So then you could just place your surface mount components on top of those and then hit it with a heat gun and kind of melt everything down. If you're really ambitious and you have a spare toaster oven, there's a lot of projects online where you could actually hook up a 120 volt relay with the Arduino and actually control the temperature and program in a certain temperature profile to act as a reflow oven. You don't want to do this necessarily if it's something that you're going to eat out of, because a lot of solder does have lead in it. I have done this with the old toaster oven just by hand. But yeah, so it is out there if anyone's really ambitious and really wants to get into kit building and circuit board building. But at the end of the day, they are harder to hand solder, but with the right equipment, it's not that bad. Yeah.
Just to note, if you are going to do that, make sure you have an anti-static mat to work on, and that you and the mat are all grounded, because these components are hypersensitive to static, and you can easily destroy them, and you won't even know it. You're gonna let the smoke out,
Yeah.
and you won't even know it. You try and make it go, and then you're wondering, what is it? How come it's not working? What did I do wrong? Well, you
Yeah.
can take anti-static measures.
Yeah. So, but yeah, especially with transistors and stuff like certain types of transistors. Yeah, you got to watch for the high voltage static. So that's all I had. Like I said, the world of electronics is too big fit into a slideshow. So the best way to learn, if you do want to learn more, is by doing. So if anyone is very interested, want to get their hands dirty, I suggest, just downloading KiCad and having at it. And then I am available if you do run into any questions. Don't feel like posting on the forums. You can just, shoot me an email. I'll hopefully be able to answer, at least point you to someone that does. So any questions?
Oh,
Yes.
I got a comment. The one application that you showed for designing the circuitry, it looked just like the voter, the same printout as the voter, and I'm wondering if the voter, they use that particular diagram. It's
The schematic that LVG has.
Yeah,
It
looks the same, doesn't it?
it's a possibility.
Yeah.
Those are pretty common across all.
I would say, I think all the EDA has the same,
The same format.
it's the same coloring, the same sizes and style. There's some slight differences between the two, but I think for the most part, it's kind of
Oh,
like,
I see.
it's all kind of a.
Just take a look at
That. Oh, magnifying glass?
with the light,
Yeah,
2 lights.
that's kind of cool.
I used to use just a simple Julius loop, and when I found that. I don't let it out of my sight. Yeah, it was trying to read the little letters yeah. When you get a component, they're so small. You can barely see the component, let alone.
So I'll give the floor back to.
Up in the light.
All right, well, thanks again. Thank you.
care.
All right, Andrew, way to go. Very nice, very, very nice, very nice. All right, what have we here? Oh, you know, Bob, maybe you want to say, I don't have a current. The last one I have is this. I know.
Nice one, but.
I know. I just, go ahead.
And the only thing we really spent in the month of October, other than the normal repeater phone and the website things, is we did spend $90 on name tags with our new thing. In terms of the repeater expenses, which we're doing separately, at the end of October, the amount we had spent, or the amount we had left from the ARDC grant was $16,007.20. However, right in November, we spent another $5,495. So what we have left now at this point in the ARDC grant is $10,520. What we have in the bank account at the moment is as of October 31st, sorry, is $21,026. Of that, of course, the $16,000 is the ARDC grant, and the club cash is $5,019.
This isn't,
64 cents, and that's that.
yeah, this is a little bit behind the times, but okay, all right, well, thank you, Bob, thank you for that. All right, what do we have next here? Oh, don't forget mentoring. I don't know if Len wants to say a word or two. I know the mentoring program.
Respond to what Bob just said. I did get a notice today that they received the check and the order and it's processing, and we should have it in a week or two. The rest of the review stuff.
All right. So
Mentoring, where I'm a little lagging behind because I've got to do too many things in one time. I noticed that several of you guys have offered to help mentor. And we're going to be following through on that and trying to put some guys together. So bear with us. We appreciate the volunteering and offering. And that's why that questionnaire, and we're going to be putting a questionnaire for both the new hands and the more experienced ones. So I have a better idea of what your interest and expertise is and what the needs of the new people are. So if you would go to the website that's coming out, it's not going to come up with a newsletter. This is going to be something that's just going to be available on the website. A questionnaire. Fill it out, and it's pretty much self-explanatory. And email it to me or the website, or however Ken ends up putting that on there, and I'll get it and I'll work with it from there.
okay, terrific. Well, thanks, Len. Thanks for that.
So
Jay, hold on just 1 second before I forget, because I just want to mention one thing. The question that was raised earlier when we were talking about the point-to-point links, the IT data links. I just want on Monday we have a Zoom every Monday that talks about that. And Dave, W8HOO, and Tony, W8VR, N8VR, sorry. Yeah, so they're working on that, and I'll get you the information. Len, maybe how do I get you on the list, and you'll get, and anybody is welcome who's interested in it, and then we can talk some serious components there. All right, anyway, I'm sorry, Jay, go ahead.
AMSAT has a very significant youth education program underway, and they have a dedicated website to get kids interested, not just can gain their license, but it's also how space, how the benefits of space and satellites and how that affects us and benefits us. And it's aimed at children. And it's very successful. It's BuzzSat, BuzzSat.org, BuzzSat. And it's part of the AMSAT education program. AMSAT also has loaner kits, AMSAT Oscar CubeSat loaner kits that they can, you make a reservation, they ship it to you, and it's a full size 10 by 10 by 10 centimeter cube that simulates a CubeSat, an Oscar CubeSat. It's got a real transmitter, a real ham transmitter, a real ham receiver in it. It's a miniature repeater, solar panels, everything that are available to be signed out. So to the education people, this is all available on the AMSAT website.
All right. Well, thank you. Thank you for that. Okay. Let us continue on here. What's next? So what do we got next? We have, all right, we thank you, our off-air monitors, listening closely and keeping the dart in good territory there. I do want to quickly go through this. I'm not going to go through every little thing, but this is every Monday night. There's a DART meeting about the ARDC grant and where we're moving ahead and so on and so forth. So this week I didn't get a chance to. We have the meeting Mondays and it's recorded and you can watch it. It's on the webpage. Thanks to John WATOY. But we also sent out a written version of it, and this is just. These are the folks who were on last week, and so there's just a few things to talk about here. So, okay, so the meeting opened up. They talked about launching rockets, and of course, this is very important because the Hazel Park Amateur Radio Club wants to be the first amateur radio club that puts a repeater on the moon. So this is very important information. So that was good that we were addressing that. But amongst more immediate things, so here we're talking about getting the information out to everybody so everybody has it. And again, apologies, we need to get our systems more coordinated with one another. And if you want to attend this meeting, we'll get you the information. Let myself know, or Len, or Andrew, or Reuben, or anybody who may be able to help there. The ARDC extension, do we have anything we want to say about that?
Up back Monday, just before the meeting, just an hour before the meeting, and they responded to our report, and they thanked us for it, and they says if we need extension, it's available. Our deadline is the 31st of January. That's the formal, not quite.
Right.
So we'll come in later in the year. We'll know where we're at and if we need to ask for it.
So that's really good news there. So, all right, and we're moving ahead. It's like a rocket taking off from the launch pad, right? It starts out very, very slow, but once we hit hyper speed, right, we'll be moving along a lot quicker. Also, there was some discussion about the controller and the bits and pieces that go together on that. Is Al, are you still with us here on tuning in? Are you with us?
I'm here, Joe, because I'm not all there.
Oh.
All right. All right, that's good. Do you have any news for us? Anything to report in terms of Len just said we got the order placed, so that's good news. I know we're working on the controller, and then we have the voter to deal with, which is a whole technological issue. But do you have anything new to report to the folks here?
Well, honestly, yeah, Joe, I mean, we did have that meeting 2 days ago, and we did discuss the future forward path is opposed to the antiquated past. And from what we're gathering, it's probably in our best interest for the voting options and the controller options is to let the All-Star voter and GPS and routers do the work. We cannot find any voters that are reasonably priced that aren't antiquated and outdated. That would probably require new circuit boards. So I guess we know how to do that, but I think we need to move forward on the networking and the 5G point-to-point relay eventually down the line. I did today work on some new maps of line of sight communications, but I do know also I'm getting caught up on this stuff. I'm a slow learner, but once I dig in, and with help of Andrew and David, which have been phenomenal, providing clarity to an otherwise muddy picture, I do believe we could actually, delete the need for a voter, an analog voter, and that controller. From what I understand, I'm sure Andrew can explain and Dave further, that the RTCM, I believe it is, the All-Star voting node, voting, I guess, terminal interface, does everything that the ARCOM controller does, and then some, and it does it all remotely. So we do have other options as to opposed to working with an inundated and outdated and somewhat cumbersome voter, which they're not even making anymore, unless we want to spend $5,000 to invest in something of the past. So I think we should take Dave and Andrews and any other networking genius out here's advice and move forward down a different path to complete our links for our remote receive sites. Now, as opposed to the UHF link into the VHF, I don't know, maybe we could probably decide and determine, is that really necessary? Do we need to link two both repeaters? Maybe they should be standalone, and the UHF can work the fusion. The new VHF will work the two receive sites and more in the future. And then perhaps if we have enough money left over, with the grant, we could maybe squeeze in a Motorola UHF DMR repeater with another coordinated frequency, and perhaps put it side by side in the second cabinet that we acquired with you, right next to the main, the VHF at the main. So there's options.
I do have a question. I'm sorry to interrupt, but did we order the controller, or what's the status on that?
No, we're not. I don't think we're gonna go the controller route. And
I got the power supply repeater and amp.
Got it. Okay.
Yeah.
All right. Good. And then a few of these other issues, the microwave system installation challenges. All right. They're up here. So, oops, sorry. I'm in the wrong. There we go. Okay. So here's, you talked about the microwave system, and there was a discussion there on how that's all, once we get the technology down and the process, it should be pretty straightforward. The water tower backup communications plan, there was some talk about that. Equipment costs, and of course where we are in the grant, which is what Bob talked about before, and some of the other, the remote access, which I guess this is not exactly what that was addressing, but something to think about too, so that we have remote control of the repeater. Yeah, go ahead.
Not on the website?
It is somewhere. It is. I bet it will be on the website. Where are we keeping these?
Yeah. The one you sent me 2 weeks ago, I posted. I haven't seen this.
No, this one just was.
Just get sent to me. I'll get it out there.
And we'll get it out. Okay, so we'll get it out. Thank you, Mike. Thank you. Yeah, I just did this morning. So, okay, sorry about that. Yeah. All right. Anyway, so that's pretty good there. All right, and that's really, I guess, the long and short of it. some other things. So we talked about the badges, so we're making progress on that. We'll get this slide updated, that's for sure. And don't forget, we have some items for sale. We just want to run through these real quick so everybody remembers that. If you have any interest at all in any of these items, I guess we're stuck. Well, that's not good. All right, stand by a minute. Okay, here.
Well, we have a moment.
Yes, go ahead.
Wants to join or renew their ARRL membership through the club. There are forms on the back table and the club gets a small commission if you do that. And the other thing that I learned from talking to Aaron Tobin the other day, his license expired in September. He was trying to renew it. The FCC website is completely offline with the government shutdown, so he's kind of off the air until we can renew his license.
Well, they're supposed to open up the government tonight.
Aaron will be the first person in there to pay his $35 or whatever.
All right, and that may be as far as we're going here tonight, but yeah. So does anybody have any questions or any comments or anything anything to say before we close shop here?
Thank you.
Well, you're welcome. And thank you, everybody, for being here tonight, and terrific. And again, don't forget, we have Monday nights, and then coming up, we'll have a board meeting here in a couple weeks, and so we'll keep you all updated on all that. So thank you, and good night, good evening, and stay warm. Stay warm. All right. Yay.